Are you sure you're in the right place? This is about science and ideas and questioning things that usually don't get questioned. Why anyone would willingly do that is already an interesting question, but okay, you're already here. So, the question is, why does science need laws? Hi, I'm CJ, and this is the biggest picture. Every society has laws, traffic laws, criminal law, religious law. We don't really question them. We grow up with them. And that's not strange. When human beings live together, something becomes necessary very quickly. Predictable behavior, trust, shared expectations. Without that, a group collapses. So every society invents rules, not because they are true, but because they work. Rules are about coordination. At first, these rules are voluntary. Simple ideas like, treat others as you want to be treated, care for the group, don't steal, don't kill. Many religions express this beautifully. Love your neighbor as yourself. These are not laws, they are ideals. They only work as long as people choose to follow them. But groups grow. Interests diverge. And inevitably, some people stop cooperating. At that point, rules are no longer enough. That is where laws appear. A law is a rule with force behind it. It says, you will behave this way, or else. And or else means consequences. Fines, prison, exclusion, force. Laws exist because humans are not perfectly cooperative. And here is the crucial point. A law only makes sense for beings that can choose to disobey it. Without the possibility of violation, a law is meaningless. When laws exist, something else appears almost automatically. Authority. Someone has to decide what the law is, how it is interpreted, and when it is enforced. Laws never exist on their own. They always come with rulers. At first, this feels reasonable. Someone keeps order. Someone settles disputes. Someone maintains stability, and for a while, it works. But over time, something changes. Laws stop being neutral tools for cooperation. They start becoming instruments of power. Not necessarily because rulers are evil, but because laws, by their nature, concentrate authority. Whoever defines the law controls behavior. Whoever enforces the law controls consequences. And whoever controls both rarely enjoys being questioned. Slowly, the focus shifts from, does this rule still serve the group? To, is this rule being obeyed? At that moment, questioning the law becomes dangerous. Not because the law is perfect, but because it now protects a structure. And once a structure depends on a law, the law becomes untouchable. It starts to feel absolute, immutable, beyond discussion. People stop asking whether the law makes sense. They only ask who broke it. This pattern repeats throughout history, religion, politics, empires, institutions, and eventually, science. Science did not invent this pattern, it inherited it. For most of human history, the natural world was explained through stories and intentions. Storms were angry, planets were divine, disease was punishment. Then something extraordinary happened. People began to notice that nature repeated itself. Not symbolically, not morally, but mechanically. The same motions, the same cycles, the same outcomes. This was new, and it was powerful. People like Kepler, Galileo, Descartes, and Newton began describing these patterns mathematically. They weren't looking for meaning, they were looking for regularity. This was the birth of modern science. But these thinkers were still shaped by the world they lived in. A world governed by kings, churches, and laws. So when they named the patterns they observed, they reached for the strongest word they knew: law. Calling these patterns laws of nature did something important. It gave science authority, legitimacy, stability. Nature was no longer unpredictable. It was governed. The universe was no longer a story. It was a system of rules. At first, this language worked. The laws described motion, they predicted orbits, they unified forces, and because they worked, they hardened. Descriptions slowly became foundations, patterns became explanations, and the word law stopped being a metaphor. It became literal. At first, the laws worked. They described motion, they predicted outcomes, they simplified complexity, and success creates confidence. Confidence slowly becomes certainty, and certainty over time becomes protection. When observations fit the laws, everything feels stable. But when observations don't fit, something subtle changes. The question is no longer, is the law incomplete? The question becomes, how do we make the observation fit? Small adjustments are added, special cases introduced. Exceptions explained away. The law itself remains untouched. Not because it is perfect, but because too much now depends on it. Careers, institutions, textbooks, entire frameworks. Questioning the law no longer feels like curiosity. It feels like disruption, and disruption carries consequences. So inquiry doesn't stop. It narrows. Only certain questions are allowed. Only certain answers feel acceptable. Over time, science becomes very good at solving problems inside its own assumptions, but much less willing to question those assumptions. This is how a tool quietly turns into a boundary, not by force, but by success. And once that happens, progress starts to look like motion, without movement. Recently, something uncomfortable happened. New instruments began looking deeper than ever before. Not theories, not simulations, observations, and what they showed did not fit. Galaxies appeared too early, too large, too structured. According to the timelines, they should not be there. Not yet. This was not a small discrepancy. It touched the foundations, and some scientists responded by saying, the universe must revise its laws. Think about that sentence. Not our models, not our assumptions, the universe. That reaction reveals something important. When descriptions are treated as commandments, reality itself starts to look wrong. But reality doesn't revise itself. It simply continues to behave as it always has. What failed was not observation. What failed was expectation. The laws were never offended. They were exposed, not as false, but as incomplete. And suddenly, the question returns. Not, how do we fix the law? But what mechanism was never understood? The universe does not need laws. Laws exist to regulate behavior. But the universe does not choose. It does not hesitate. It does not obey. Atoms do not follow rules. They interact. Galaxies do not respect authority. They evolve. When we say the law of gravity, we are not naming a command. We are naming a pattern we noticed. The mistake begins when we treat that pattern as the cause. The universe does not behave because a law tells it to. It behaves because something physical is happening. Structure, interaction, flow, geometry. Once you see this, the idea of physical laws quietly collapses. They were never wrong. They were just never fundamental. They were summaries, mistaken for explanations. And when explanations are missing, science doesn't need new laws. It needs new questions. If we stop asking which laws the universe obeys and start asking what mechanisms produce what we observe, a very different kind of science becomes possible. Not one built on commandments, but on understanding. What happened for me when I stepped outside patchwork science wasn't that answers suddenly appeared, it was that the noise stopped. The moment I stopped treating laws as commandments, I could finally follow mechanisms all the way through. The physical world became mechanical again, not abstract, not mystical, but something you could actually reason about. This is the structure that emerged from that shift. I'll show it briefly. Pause if you want to read it. Some of these chapter titles look ambitious, but they all grew out of the same refusal to accept descriptions as explanations. What is the physical form of the electron? What is the physical form of the atom? Why does mass resist motion at all? What is gravity, mechanically, not mathematically? What is light actually doing as a process? Why do existing atomic and nuclear models fail? Why did the ether experiments fail, physically? What is really going on in entanglement, in radiation, in black holes, in cosmic expansion? These questions don't compete with each other. Once you stop patching models, they start lining up. I'll explore many of these mechanisms here on the channel, step by step. But the full structure, from subatomic form to cosmology, is already written down in my book, The Universe is Flow. You'll find it on Amazon. The link is in the description, along with the complete chapter list. And once you see how the pieces connect, you don't really unsee it. If you do read it, leave a comment, because I am so curious what you experienced when the coherence became visible. Are you still here? Then we're probably done. But since you made it all the way to the end, you already know what this channel is about. So, yes, you can like it, or subscribe, or not. I'll be here either way. The next one starts where this one stopped.